name's Nicole. I'm from the Ann Arbor Hands-On Museum. Today, we are going to be talking about magnets. During this video, you can either pause it whenever you want to do the activities yourself, or you can wait to do them until the very end when you're all done watching. My first supplies are what I like to call junk drawer supplies. They're just kind of whatever you have lying around, little bits and pieces of things. So for example, I have this plastic letter M, a string of beads, a hair tie, a plastic cap to something, a little bit of a pipe cleaner, a couple of screws, a couple of different coins, a paper clip, a thumbtack, a die, a binder clip, I have an old key that doesn't work anymore, a piece of felt, and I have a colored pencil. So those are the junk drawer supplies. Beyond that, you'll also need some things that are a little bit flatter. So you could use this cloth again. I might also use a piece of wood. This is all I have, one that's attached to something on the bottom. You could use a coaster. You could use some cardboard. You can try with different thicknesses of cardboard too. You can also use paper. You can try different kinds of paper, different thicknesses of paper, or different amounts of paper. So I have this whole paper pad, for example. I could use just parts of it, or I could keep it all together and use different parts of it as I go. The most important thing that you'll need to do this lab is a magnet. There are a bunch of different kinds of magnets. You just need to find one that you can play with today. So I have some magnets right here. I have one like this. This is a ceramic magnet. This is a magnet that was just on my fridge. It's plastic on this side, but the magnet you can see on this side. You even have a Hands-On Museum magnet. These are little magnets too. You can take them apart. Each one is its own magnet. One thing that I should mention, make sure that you keep magnets away from things like credit cards or electronics because they often have magnets or depend on magnets, and so you might mess them up a little bit. So just play with the things that you know are okay to play with. So that's all you need. You need a magnet, you need some junk drawer supplies, and you need some things that are flat. You can either pause this video and go find those things now to do it with me, or you can wait until the end of the video and do it then. So the first question is, what is a magnet? A magnet is any object that is made of certain materials which give it a magnetic field. Magnets are all around us, even where we don't usually think of magnets being. Magnets are how we microwave our food. You can also find magnets in refrigerator doors. They help keep the refrigerator closed. Sometimes our laptops have magnets in them too. There's magnets in food processors. Magnets sometimes keep cupboards closed. There are magnets in old computers. Some bags or jewelry have magnets to hold them closed too. Like right here, these little snaps are actually magnets, and they clip together to keep this bag closed. If you have any big speakers, those speakers have magnets. Also, our smartphones have magnets in them. There are magnets in vacuum cleaners. This book has a magnet. The magnet is in the latch that keeps it closed. The first thing I'm going to do is go around and use my magnet to find which things this magnet will stick to. You can try this in your own home. Just remember to stay away from electronics or someone's wallet. Do you think a magnet will stick to this hammer? Yes, it sticks to the hammer. Look at that. That means that the hammer is magnetic. Do you think a magnet will stick to this tissue box? Nope. That means that this tissue box is non-magnetic. Do you think a magnet will stick to this wall? Nope. What about this lamp? Do you think a magnet will stick to this lamp? Yes. Do you think a magnet will stick to the fridge? Let's see. Yes. So that's what's magnetic and non-magnetic around my house, but you can find things around your house too. All you need is a magnet. For the first experiment, we are going to take the objects that were our junk drawer objects and test to see if they are magnetic or non-magnetic. For this first experiment, it helps if you have a piece of paper, but you don't need one. On this sheet of paper, I'm going to write two things. Non-magnetic. Put a line down the middle. And then on this side, I'll write magnetic. Just like that. So these are my two categories. The first step is to take your junk drawer items and you need to sort them between magnetic and non-magnetic. This first part you do without a magnet. We're just going to make guesses. These are called hypotheses. We're going to make hypotheses about these objects. We're going to decide if we think that they are going to be magnetic or non-magnetic. So now I'm going to take my objects and I'm going to sort them into these two categories, magnetic and non-magnetic. All right, let's see what I think will be magnetic and non-magnetic. So this is how I sorted my objects between non-magnetic and magnetic. Now that I've sorted them, I can use a magnet to test if they are magnetic or non-magnetic. All I need to do to test if something is magnetic or non-magnetic is to use a magnet on it. Let's try the screw. It does stick to it, so that would be magnetic. Let's try the other screw. Oh, it also sticks to it. No, the fabric doesn't stick to it, so that is non-magnetic. What about a penny? I put it in non-magnetic. Let's see if it's magnetic. It's non-magnetic. I want to try this old house key. Oh man, I got one wrong. This one is non-magnetic. Let's try the paper clip. Magnetic. Let's try this plastic die. Non-magnetic. Let's try the binder clip. It's magnetic. Let's try this colored pencil. Non-magnetic. Let's see, what about this hair tie? Is this hair tie magnetic? Oh. Let's try this string of beads. Non-magnetic. Let's try this push pin. It's magnetic. I put this pipe cleaner in magnetic. Let's see if it's actually magnetic. Whoa. Let's try the dime. Maybe the dime is different than the penny. I still put it in non-magnetic. Nope, the dime isn't magnetic either. What about this plastic cap? Nope. If I just hold on to the magnet, this falls right off. Let's try this M. Nope. Non-magnetic. So now that I've tested all my objects, I know which of them are magnetic and non-magnetic. All the things that were magnetic had something in common. Did you notice what it was? For something to be magnetic, it needs to be made of metal or have metal in it. Not all things that are made of metal are magnetic, but if it's magnetic, it will have metal in it somewhere. So let's take another look at the objects that we sorted and tested. It makes sense that all of these were non-magnetic. They don't have any metal in them. And it makes sense that the paper clip and the screws were magnetic. They are very clearly made of metal. But what about some of the objects that were a little trickier? Why were they magnetic or non-magnetic? We have this pipe cleaner. This pipe cleaner might look fuzzy on the outside, but on the inside it's actually made of metal. That's why we can twist it and it holds its shape. And that metal is magnetic. Our binder clip and our hair tie, although they're not completely made of metal, they have metal parts on them, and those metal parts are magnetic. What about our coins and our key? They're made of metal. Why weren't they magnetic? Remember, not all metals are magnetic. You may have noticed that magnets seem to have two sides to them. These sides are called poles. We call the two magnetic ends of the Earth poles as well, because the Earth is basically just one big magnet. So, what do we call the pole that we think of as up? Right, the North Pole. And that's what we call one of the poles in the magnets. What do you think the other pole is going to be on the magnet? Right, the South Pole, just like on our Earth. So we have a North and a South Pole on a magnet. One side's north, one side's south, just like our Earth. You may have also noticed, if you have more than one magnet, that magnets like to stick certain ends together and other parts kind of bounce off each other. These are the poles that are reacting to each other. And we can show you how that works just with our hands. So, everyone give me 2 thumbs up, all right? Now these thumbs are pointing up. So which pole do you think they're pointing towards? Right, the North Pole. So we'll pretend our thumbs are the North Pole. Now, you can try, but you can't really get your fingers to link together and hold each other's hand if you have 2 North Poles. That means if you have 2 North Poles, the magnet ends will repel. Now let's see what happens if you have 2 downward pointing thumbs. Which pole do you think these are? Right, these are the South Poles. So if we put 2 ends of South Poles together, nope, they don't stick to each other either. But what if we took our 2 hands and did 1 South Pole and 1 North Pole? They can grab each other and stick really hard. That is how a magnet works. So when we have a South Pole and a North Pole, the magnets attract. So now is a great time to play around with the magnets that you have. You can play around with their poles and see when they try to bounce off each other. Oh, I turned it upside down. So you can make your magnets dance too. And play around with them. Now I'm going to tell you a little secret. Magnets are sometimes how people do magic tricks. So, if you've ever seen something float in the air, it might be magnets that are doing that. Remember how I said the magnets have a north and a south pole? And if you put a north and north side together or a south and south side together, they'll repel. Because they repel, they actually can fight against gravity and make things float in the air. Now we'll talk about something called the magnetic field. A magnetic field is the area around a magnet that the magnet can attract or repel things. So here I've drawn a magnet. The red and the blue just indicate the north and the south poles. A magnetic field is an area around the magnet where the magnet works, meaning where the magnet can attract or repel objects. Now we're going to test how big that magnetic field is for our magnet. I'm going to use the magnet that I have and a paper clip. Now all you need are those flat objects. So like my coaster or my paper. And what you're going to do is you're going to place your paper clip flat on your palm, okay? Next, you're going to put on top of it what you want to test the magnet going through. So I could use these little pieces of cardboard, and I'm gonna lay that now on top of my hand. Then I'm gonna put my magnet on top and make a magnet sandwich. Then you lift up the middle piece and see if it makes a sandwich. It does. If you look, the paper clip is stuck to it. That means that the magnetic field can go through this cardboard. Let's see what else the magnetic field can reach through. We have this coaster. Wow, it reached through the coaster. Now I'm going to try this piece of wood. Wow, it can go through the piece of wood too. So now I'm going to try this magnetic field through this paper, and I'm going to try it at different widths to figure out how big it is. So first, we'll start with the whole thing plus that cardboard on the bottom. So I put my paper clip flat on my hand, put this on top of it, magnet on top of that. Let's see. Oh man, nope, it sticks a little bit, but it can't hold on. The magnetic field isn't large enough to go through all of the paper and the cardboard. What if we take out the cardboard part and do it just with the paper? Nope, it is still too thick. Now I'm going to make the paper even thinner and see if it can go through that. Oh yeah, look at that. The magnetic field is big enough to go through all of that paper. You can also try layering your different flat pieces to see if it can go through multiple things at once. What about the paper and the fabric scrap? Let's see. Yep, you can go through that. What about this and the wood? Oh, it sticks a little bit, but the magnetic field isn't quite large enough to go all the way through. So you can play around with your own flat pieces and see how thick the magnetic field is that it goes around your magnet. Another property of a magnet is its strength. Magnets have different strengths. I have two magnets here. One of them is this large ceramic magnet. It's actually pretty hefty. Another is this little tiny ball magnet. Now, which do we think is stronger? So we can test the strength of these two magnets against gravity, another force. So here is a tin, and this tin is magnetic, meaning a magnet will stick to it. And we can see that gravity pulls on the tin. But can we get a magnet that can fight against the force of gravity and hold up this tin? Let's check it out. So here we have a magnet. Remember, this is the bigger magnet. Let's see. It doesn't want to lift up this tin. Now let's try this smaller magnet. Wow. I'm not holding anything but that little magnet, and it's picking up the whole tin by itself. That means that this little magnet's actually stronger than this bigger magnet. This little circle magnet is something called neodymium. Neodymium magnets are super strong. Even though it's really small, it can hold a lot more and attract a lot more than this magnet can. If you haven't done so already, you can now take your own magnets and do the activities yourself. Have fun exploring with magnets and their poles, their strength, their magnetic fields. Thank you for tuning in to the Ann Arbor Hands-On Museum. Bye!